Hello, welcome to Physics Studio. Over the next 4 days, as a way of getting into periodic motion, we're going to be doing a little project, and it's going to involve one of the great questions in physics, which is, how does the pendulum work? And if you want to research this, it goes back to Galileo, but what you're going to be doing is building a pendulum with household materials, and you're going to carry out controlled experiments and figure out how it works. So what I'd like to do right now is I want to give you some of the theory behind this, and we're going to pose the research question and then figure out what the deliverables will be over the next 4 days. So let's take a look. Okay, so what we're dealing with now is periodic motion. And you all know at this point that periodic motion is motion that repeats itself over and over again. And because it repeats itself, there are a couple variables and technical terms we had to introduce. So just by way of review, the first is the period, or tau. That equals the amount of time per cycle, right? The amount of time it takes to go through one repetition. And the units for that are seconds per cycle. We also have frequency, which equals the number of cycles per unit time, which also equals inverse of the period, which I think you figured out. Then we have a term called the cycle, which is what repeats. And it's easy to identify the cycle of a periodic motion. You just pick some point in the process, any point at all, and you follow the process out, you observe until it comes back to the starting point. That's one cycle. Now we also have something called the system, which is everything that affects the periodic motion. And ultimately the system is the universe, but for practical purposes when we're doing experiments, you want to take account of everything that affects the motion, and you don't want to have to bother with stuff that doesn't affect the motion. So we're not going to worry about the political system or, changes in the sense of sovereignty in the EU or something like that. It doesn't affect the periodic motion here. But we do have to figure out what does affect it. And so we're looking at a pendulum. And the example that we used before, which is a perfectly good pendulum, was the example of a kid on a swing. So here's our kid. Right? And that kid's up at this point of the swing, and we know that they're gonna follow an arc like that. Right? They're constrained to move in that way because of the pendulum. And end up over here. And so they swing through this up to here, then back to here. That's one cycle. That's how a pendulum works. They all work that way. One's on clocks, etc. The weird thing about a pendulum is, and it's because it's a special kind of periodic motion called simple harmonic, is these cycles are extremely regular through all sorts of different things. So the time it takes, the period it takes to swing through the pendulum is exactly the same given the same conditions for all the repetitions. Now, what we want to identify here is what goes into the system. And we know there's a pivot point up here. And that's got to be attached to something firm, like a ceiling, or it could be the frame of the swing set, or a beam, or something like that. And without that, the kid's just going to fall, right? So that's what constrains the movement in a circle, in a circular pattern like that. We need a length of string, or twine, or thread, or chain, or something like that. And we need a mass on the end of it. Without the mass, it's just going to flap. You know, the string is just going to flap like that. So the mass gives it stability in some ways. We also know that when the kid's up here, he or she is going to start accelerating this way because gravity is pulling on it. And so we also need in our system the earth, or whatever the source of gravity is. Now, in defining these, that string or rope or chain is going to have a certain length, L. And this object on the end is going to have a certain mass, M. And so, to simplify this, I'm going to get rid of the kid now. Though you can keep thinking of that because that's your own experience of pendulums. And let's just put a generalized mass on the end, like that, with mass M. And that's our pendulum system. So in terms of variables, we have length in meters, we have mass in kilograms. Now this thing is swinging through a certain angle. We have theta, like that. And you know that if you're on a swing set, the greater that angle, the more exciting it gets, right? Because you have more energy in the system, things go faster. So that angle is significant. And we also have G, which is in meters per second squared, acceleration due to gravity. Now, in designing an experiment, two things are going to go on. You're going to have to pick your materials for this, right? So you have to find a pivot point. And you have to find a rope or string or chain. And you have to find masses to put on the end. And you need a source of gravity, G. And then these up here we will call our variables. Now, insofar as you're going to carry this experiment out on the surface of the Earth and you're not going to go up to the top of Mount Everest or carry it out on the moon or on a satellite, G is controlled for, right? So that's taken care. We've taken care of G for you. You don't have to worry about it. Now, theta, I think to keep things simple, we're going to keep theta constant. So you're going to find a place where you pull it back and release your pendulum. And you're going to always keep that constant, right? Your angle is going to be constant, maybe 10 degrees, maybe 15 degrees, maybe 20 degrees, something relatively small. What we're concerned with then is what the effect of the length and the mass are on how long it takes to go through a cycle. So, our research question is as follows. Which has a greater effect on the period of a pendulum? Length or mass? And what you're going to do is you're going to build out of simple household materials a pendulum. You're going to carry out controlled experiments to test for length and mass. We've already controlled G for you. You're going to control theta and keep that the same. If you're testing for length, that means you're going to have to be able to vary the mass. And it's not so easy because probably most of you do not have a highly accurate scale at home. So you're going to have to find some way to consistently vary the mass without the scale. If you're testing for the effect of mass, you're going to keep the length the same and change the mass. If you're testing for the effect of length, you're going to keep the mass the same and make it successively shorter and shorter, or longer and longer, either way. That's your task. Then once you've done that, you're going to come to a conclusion about what the most important things are affecting, which is more important in affecting the period of the pendulum. Now, given that, here's what you're going to be delivering over the course of the next couple of days, or 4 days. On day 1, you're going to assemble materials, which means you're going to go around your house and find what you might use to make that. And your deliverable, what you're going to submit, is a picture of your materials. Day 2, you're going to build your pendulum. So you're going to take these materials, you're going to have to find a good fixed pivot point and your length of twine, string, or chain, and you're going to have to figure out a way to vary the length and the mass and put that together. And what you're going to submit is a short video of your pendulum in operation. So you have 2 full days to get to that point where you have your pendulum working. Day 3, you're going to do controlled experiments testing the effect of length and mass on period. And what you're going to submit is a data table. And we've done this enough, that at a minimum you need to have you need to have at least 3 variations for each variable. Then day 4, you're going to submit your conclusions in the form of a 1-page report plus a graph. And let me just underline, right? This is your deliverable on each day. And 4 working days is going to be almost 2 full weeks. So you have some time to work on this. I'm thinking 5 points, 5 points, 5 points, 10 points for the total project over the course of 2 weeks. And I think what this will do, it'll allow us to build this up step by step and give you plenty of time to work on it. Now, I'm going to follow this up with another video where we go through and look at some household items that might be useful in finding a pivot point, your string, chain, or rope, masses, etc. And we'll talk a little bit about some small safety issues with it. So, good luck. I know that as soon as I posed this question, you started thinking about this, so go ahead and get to work on that. When I deliver the second video with household items that might be useful, just cross that with your own thinking and come up with your own idea. I always really look forward. There is no way to predict what you're going to come up with when people are thinking on their own. So good luck with this. I look forward to seeing what you come up with.